Good morning, this is Tristan Price recording a walkthrough of the Memory Management Program uh, MMU Emulator for CST-321 Operating System Fundamentals. First thing we're going to look at is the program code itself. So I have my include. It looks like this one only needed the standard I/O include, so that was kind of cool. So the first thing we're going to do is actually define the required memory. So the virtual memory is going to be 0x000FFFFF, which is what was requested in the instructions. And then, of course, for the physical memory, we've got a different number here. And Visual Studio Code actually shows us what the int looks like for those hex codes. So that's kind of neat. And then, so the first thing we have to do is create a binary converter. I'm a fan of using the iterative according to Geek for Geeks. The iterative seem to have a smaller O notation for big O notation for the algorithm for it, so I went ahead and used that. So this one we wanted a 16-bit number per the parameters. So I went ahead and wrote that. So we're going to iterate through 16 times, and then we're going to have a little 16-bit array this time showing the 16-bit binary number. And then I had to define the page table. We wanted an array that would support both sizes of page that was input. So this one will kind of actually support any size of page that's input, but it will definitely support the 4K and the 8K page size. So what it does is it looks at the virtual memory and it divides it by the page size, and then it iterates through to create the pages. And then, so that's going to be that function. And then this function here is for converting the virtual memory to the physical memory, or mapping that on there. So it looks at the page table size and the page size, and then it does some calculations down here to create a page table index that actually goes to the physical memory, and that's how it's going to go ahead and return the physical memory location. This modulo is going to allow it to actually go at the correct location within the physical memory on the page. So those are the three functions that we are going to use in this program. And then down here I have my main function. So I have a couple of variables that I have to define. One of them is the page size, the other one is the virtual address. And then here's where we get our user input. So I have a choose a page size 4095 or 8191, and then we're looking for that page size so the user can enter it. So then we went ahead and got that binary size defined. Then we're going to convert the page size to the binary. We're also going to show it as a hexadecimal. This is going to be our code for special code for showing that we want it to be shown in the hexadecimal. Down here, we're going to set up the paging table for a conversion. So the page table size is going to mirror what we had up here to go ahead and get that going. Once we have the page table set up for that conversion, we're going to go down here and ask for the just the memory address. This has to be entered as a decimal. And so once we enter a decimal virtual memory address, then it will print it out to tell us what we got in hexadecimal, and then finally it will convert it to it will map it onto the physical memory. And then down here we're seeing if it maps to physical memory or if it is on disk. So if the physical address that we put in is smaller than or equal to the physical memory, it will print out the address. Otherwise, it will tell us that it is currently on disk. So that's going to be the walkthrough of the code. Now we can go ahead and see the function of it. So the first thing that we're going to do is choose a page size. And then that tells us, at first this kind of tripped me up because 8K is 3 zeros followed by all ones, and 4K is 4 zeros followed by all ones, so it took me a second to make sure that that was working. And then we have our hexadecimal value there. So then we need to enter a virtual memory address. So we'll do 543210, see if that one works. So that one is a little too large. It is currently on disk. So if we do our MMU again, let's do 8191 this time. And then you can see there's those 3 zeros and the 4 ones. And then we have a different hexadecimal on that one. And then let's do 43210. That one, the memory is actually in the physical memory. And then as we continue going through, that one is too large, it's currently on disk. And there you see that that works just fine. Oops, I entered that in the wrong spot, that's okay. And that puts it currently on disk. Etc. So you see that that functions just fine, and that is a walkthrough of my MMU emulator for CST-321. Thank you for watching.